So let me go ahead and explain to you how Chapter 7 is going to work. Chapter 7, there's going to be three types of questions. The first one, uniform distribution. Uniform distribution is pretty much regarding the only thing we cannot manipulate or control, and that is what? Well, time. Okay? The only thing that we cannot control and manipulate. So that's why it's uniform. Because what's the only thing that you can rely on? That you can't do anything about time. That's the only thing you can rely on. Time is going to keep going no matter what you do, no matter who you are, it's going to keep on going. So that's why it has a uniform distribution, which means it looks like a what? A rectangle. It doesn't change. Time is the same here at 10 years. Let's say you're 10 years old, 20 years old, 30 years old. It just keeps on going and there's no variation whatsoever. It may feel like it when this is called relativity. When you're 15 or you're 12, you think it takes forever for you to get to 15 so you can what? Drive. But then when you're 50 or 60, you feel like tomorrow you're going to die because time is going faster. But it's not. It's going the same. Another theory of relativity. You sit in my class and it seems like it's 3 hours long. But you sit in a movie and it feels like it's only an hour. Why? It's relativity. You're enjoying the movie and you're dreading my class. Okay? The whole point is, does time change? No. Your perception of time changes, which is called relativity. All right? So that's one question you're going to get. And this could be minutes, it could be years. Most of the time, this is minutes. Most of the time, because you're talking about being late for a class or standing in line at the bank or whatever. Most of the time, it's minutes. Okay, the second type question. The second type question is going to have to deal with normal distribution. And you're going to be given 0 as the mean and a standard deviation of 1. And these are going to be pretty simple because all you have to do is convert to a z-score, find the area, or the area, convert to a z-score. All right, so those are going to be pretty easy. The third one is the one that's not going to be easy. I mean, not easy, just more challenging. And that is the normal distribution, just like that one, only this time the standard deviation is going to be 100. And the mean is going to be 100, and the standard deviation is going to be like 20. Oh, sorry, 80 and 60. Okay? So those are the three type questions you're going to get in 7.1, 7.2. Now, we used to use the table. And if you don't have a graphing calculator or a TI 84, 83 or above, then you're going to have to rely on the table. The table is in your book. You should have a cardboard table somewhere in there that opens up into 5 different tables. This is called the Z table. Okay, so look for that table and then we'll go from there. Okay? And you only need the table for these. Okay, or use your graphing calculator. I'm going to predominantly use the graphing calculator because it's a whole lot easier and quicker, and most of y'all are on the calculator drill team in high school, so y'all twirl it around like a basketball on your finger. So anyway, let's go to the next thing. So the question will ask for uniform distribution. Teacher has a 50-minute class. What is the probability that he or she will go over 40 minutes? All right, now it may not be the same numbers, but it will be that type of question. Now, of course, you're dealing with time, so it's uniform distribution. It's not going to tell you use uniform distribution. And you draw your table. 10, maybe do it in fives. 5, 10, 15, 20, 25, 30, 35, 40, 45, and what? 50. Everybody with me? And we know that the distribution looks like that. And what do we know under all probability? What is the area under the curve? What's the highest number we can have in probability? 0 to what? 1. So what's the area under the normal distribution as well as you could think of it as 100% or 1. So I'm going to use, since we use decimals, the area is always going to be equal to 1. Now I'm going to use 4 digits because in this chapter, and let's write this down, 4 decimal points usually equals the area. Sometimes it's called the area, sometimes it's called the probability, sometimes it's called the percentage. So you need to get used to that in chapter 7 because it could be written any. So 4 digits, 4 decimal points is area, probability / percentage. 2 decimal points is usually equal to a z-score. Okay? As far as I can get it. So.
Oh, no, I can see. Thank you.
So what do you do first? Well, the first thing you do is you find the height. Well, first thing you got to do is you got to remember what's the area of a rectangle. Length times what? Length times width, or base times what? Is equal to the area. That's the first thing you got to remember. So therefore, number 2, 1 is equal to, what's the base of this rectangle? 50 times the height, and then solve for h. So the height of this triangle, the height of this rectangle is 1 over 50. Sometimes it will ask you to calculate it. Sometimes it will be given. Write that down. Sometimes in the question, it will ask you to calculate. Sometimes you will be given. Okay, I'm walking back here, so make sure you hide all your laptop stuff. So 2 or 3 of y'all are not working on math. I don't know why y'all keep trying to do that, but. So now, I'm going to take a red marker, and I'm going to draw a line at where? Now, what does the question ask? Go over or less? over, so it'd be this area right in here. So I want you to calculate that area in red, and that's number 3. Area equals base times the height. So what do we have?
1 times 10.
No. 1 by 1.
1 times 10.
Where did you get 1?
There's a 1.
No, you're finding the red. You're finding this area. So A is going to be what you're finding.
Be 110.
Well, what's base? I asked what was base. I didn't ask what was the answer.
40.
Base is what? What's the difference between 40 and 50?
10.
Well, say it. Y'all sound like a bunch of children. All right? Now, don't blow me out. I know that's what you're fixing to think about doing.
Oh, yeah.
All I want you to do is just articulate and volume, like I do. Not. All right. Now, what's the height? 1 over 50. Thank you back there. Thank you. And let's see if we can do this math. Now, I'm going to show you a trick I learned in the war. You can cancel out those zeros. You don't have to use a calculator here. You get 10 over what? 50, which is 2 over 10, which is point what? And technically it's 0.2000. But what kind of percentage, or what you say 0.2 probability, or there's a 20% chance that that teacher is going to go over 40 minutes. 20% chance, or 0.20 probability. Technically, I usually put 4 right there. 0.2000 probability that the teacher will go what? Go over 40 minutes. Now that is how you do uniform probability. On the Chapter 7 material, you're probably talking about 2 questions on the test. Is this a standardized test question? Yes. Now, you may not see it the first time you take it, but you might see it the second time you take whatever test you're taking, because that is a test question. In this Chapter 7 material is on standardized tests. Okay, who's got a question? So, you use the black area, you use the 1.00 in part 2. Well, we did it up here, sorry. 1.00 is equal to 50 times base. And then you solve for the base or height, whatever. 50 times height, sorry. You use that area in part 2 or part 1, wherever. There's where I did it, part 2. It's right there. Okay? And then in the third part, that's why I did it in red, you're not using this area, you're finding this area. So could I say, what is the probability that he will go less than 15 minutes? You would do on this side, right here, less than 15 minutes. Capiche? That's uniform distribution. Now, why am I not showing you another one? I don't need to. It's either going to be to the right side or it's going to be what? To the left. Because you have in class and you have what? Out of class. So it's not like you have any other options. Okay? So that's that one. Uniform distribution. The second type is a normal distribution. Normal distribution, and they're going to say, now you might want to, as I told you before, I told you that you might want to go, and this is where you need to, for the one person that's going to do this, copy and paste about 6 of these normal distributions on one page and print out about 10 pages. Chapter 7, 8, 9, and 10 is where you're going to be drawing these things over and over and over. Okay? So for the one person that's going to do this, you might want to do it in this section, because it's very hard to do. You've got to type in normal distribution, z-scores, and then you find one with percentages, and you have to print that out. You have to hit print, and you have to copy over. So it's a lot of work. 0, 1, 2, -1, -2. Do you have to remember your empirical rule here? Yes, because you use the empirical rule to check your answer when you're done. So the empirical rule, and I'm going to go ahead and write 3 standard deviations, because I think this book goes to 3. We know this is 0.15, this is 2.25, I think, or 2.35, that's 3. 0.35, I believe. And then 13.5, 34, 34, 13.5, 2.35, and 0.15. Now that is what you would like to have to copy and paste, like 6 on a page, and then print out like 10 of those, maybe even more. Okay? Now, we're going to leave that up there, and I'm going to write a question down here, and I'm going to say, what is the area greater than 1.6? And usually if they give you 2 decimal places, that means this is equal to a what? A z-score. So the first thing I'm going to do is I'm going to plot. Take my red marker, and I'm going to plot z is equal to 1.60. There's 1.5, so 1.6 should be right in there. Now, is this like building O-rings for the space shuttle? No. This is guesstimated. So where you plot it is not got to be perfect. All right. Now I want to ask a question. What does the question ask for? To the right of that red mark or to the left? Right. To the right. So I'm going to shade in the right. And the second thing you do after you plot and shade, the second thing you do is guesstimate. Okay, so 2.5. Now, half of 13 is 6, right? No, really, it's year 7. Shut up. Okay? You know what I mean. What is half of 13? 6.5, right? All right. So this is going to be less than 6.5. So I'm going to say it's going to be about 6% right there. And then what's 6 plus 2.5? 8.5. So I'm going to guess squiggle equals with a dot on it 8.5%. Now why am I guessing what the answer is? Say what?
It's not exact.
It's not exact, but it will be close enough to tell me if I'm doing something wrong with my what? With my calculator or my table. And then 3, you're going to actually do the math. Okay? How do you do the math? Well, you can do it with the calculator or you can do it with the table. Now, those of you that have a table, I'm going to pull one up for you to show you what it looks like. Because Now, if you can't use just any table, because this book's questions is going to be directed toward this book's table. Somebody tell me, which book are we using? Sullivan? Somebody look in front of it and see who wrote it. Is it Sullivan?
We didn't even. It is on E-Tech.
There should be a title page.
Yeah, I'm looking right now.
Thank you. I thought somebody might have, I told you not to buy a book, didn't I? I told you not to bring anything to class too, didn't I?
No, you told us not to come.
I told you not to show up too. So I'm going to type in Sullivan. I think it's Sullivan.
It says Pearson.
What? Pearson is the publisher. Who wrote it?
I don't know what it was.
Huh?
It's loading.
What did he say?
It's loading.
Oh, I thought he was saying a name.
No,
I'm sorry.
I said it says Pearson E-Tech. I didn't say like.
Okay, Sullivan Z table. And you might, let's see, I don't know if this is Sullivan. Yeah, see, I'm just going to pull up Monroe State University because it says Sullivan. So if we're in Sullivan, this should be.
Michael Sullivan the
Yeah,
third.
that's what it is. So look at it. I'm just showing you this. This is not, I'm not saying this is the same one that you have. Come on, where are you? There we go. Let's see, is that Z? Nope. There we go. All right, here is the table. Now, of course, I'm going to try to blow it up for you. This is what your table looks like. Everybody with me? Now, I want everybody to look at this diagram right here. For those of you that's going to use the table only gives you the area to the what? To the left. So if you need something on the right, you got to take the complement. So let's write that down. And, you know, I can't, well, just go ahead and write it down because I don't have everything pulled up. Well, let me go ahead and pull up.
I just look at that one minus thing. We did it.
Y'all did this in class?
I did it in class.
Okay. This is very important for those that use the table. The table only gives you the area to the left of your mark. Therefore, complement for right-hand side. So right-hand side is equal to 1 minus what?
The table number.
The left-hand side. And the table gives you the left-hand side. Now that's very important if you're going to use the table. Now you also need to remember on some standardized tests, they don't let you use what? A calculator. They're trying to make everybody be able to do that because some of y'all are so dependent on a calculator. Not y'all in here, but y'all meaning, so, you know, and we'll continue to have people that can't spell mom backwards. But anyway, you be able to use the table. Now, my area, or my Z-score, is a positive Z-score. So right now, all I've got is what? On the left-hand side, what are those? Negatives. Thank you for the interaction. I appreciate it. All right, so I'm going to move down. If I can work a PDF, because I'm not used to working PDFs on this board. So I need to find, what did I say, 1.6? Now the top, look at the top. The top, you got 0 cents. 1 cent, 2 cent, 3 cent, 4 cent, 5 cent, 6 cent, 7 cent, 8 cent, 9 cent. Does everybody understand that? I'm saying cents because that makes more sense to you. Over here, you got your dollars and your 10 cents. So negative $2.70, negative $2.71, $2.72. Get it? Now, I'm going to come down And I know that first column is 0, this last column is 9. You need to remember that because you're not going to be able to go all the way up to the top. It's easier just to count over. So I'm going to go down, and I'm going to find 1.60 because that's $1.60. So here is 1.6. Let me take my handy dandy red pen. And there is my area to the left of my curve, of my point. So write that down, 0.9452. I'm going to draw this up here. 1.6. 0.9452. So that's 95%. 94.52%. So somebody take your calculator, which you really don't need a calculator because that's going to be 0.548, right? And that's going to be 5.48%. Now I said 8.5. That's good enough. Now what if I had 19.6%? Then something's wrong. Okay? It needs to be in the area of your, your thinking, your estimate. So our answer to our question is, let's go back to our question. And y'all remember these numbers so I can write them down on the... I've had trainings. I can't get it to work right now, but there we go. So I found this area with the table. And that's what was it, 9.457, what was it?
2.
Okay, I forgot.
9.45.
Thank you. 9.452. And therefore, this over here, I'm going to say 1 minus 0.9452. And that's going to be equal to whatever I said, 0.0548. Y'all check me?
Yes.
And that is that area right there. And that's how you do greater than. Now, take your handy dandy calculator. Let's get it out. Pull up your handy dandy calculator, and I've got to remember, because like I say, I don't use a calculator every day. As a security blanket. So let's go with second. Let me make this a little bit bigger for y'all. There we go. I think it's second bars. And I think it's normal PDF, I think. Let me try it and see. So I want to go from 1.6 to infinity. Now I can't type in infinity, so I'm going to think of a BA number. The bigger you make it, the more accurate it's going to be, but after 2 or 3 digits, it's the same, so it doesn't matter. I tell students more than 3 nines. So make sure you use 3 or 4 nines at least. Enter. Okay, it's not that one, so it must be normal CDF. Let me try second bars, normal CDF. 1.6, comma, 9999. There we go. Write down normal CDF so I don't forget. All right, normal CDF.
I have a question.
Yes.
All right, so when our calculator using the 83, so for us in 84, it goes straight to.
Hold on. Oh, I would do so much for y'all. So second VARS, normal CDF, is probably going to ask you for each one.
Yes.
All right? So the lower, which way do we read? So what's our lower end? 1.6. And what's our upper? 99999. You can put 10 nines if you want to. And paste. Now the good thing about the TI-84 is when the questions change, you don't have to change your procedure. You change the mean and the what? Standard deviation. Okay? See? You can change that on the TI-84. On the TI-83, you have to change the Z-score by hand. I think. I'm pretty sure you do. So hit paste and enter, and it's a miracle. So I just showed you how to use the TI-83 and the TI-84. And if you've got anything above a TI-84, it should work the same way. Settle down. All right, now that's above. Now let me give you one that you may not know how to do. Because my job is to try to discourage you. All right, here we go. So I'm going to just start another problem. That means I have to draw it again, but so here's the problem. Find the Z-score at your 76th percentile. You might see a question written like this. So write down that P sub 76 and highlight the P sub 76 because the P sub 76 means what? This right here means 0.7600 because this is a, what does that P stand for? Percentage. What did I say? I said 76 what? Percentile. 76 percentile translates to 0.7600 area. So you might need to make that note. Well, what am I going to do now? Draw a picture. Now, some of you LADers and water walker wannabes are going to say, I don't need to draw a picture. Okay. Don't what? Don't cry when you get 1, 2, or 3 wrong on the test and you don't know why. Okay? And I'm talking mostly to the males because y'all don't need stuff like that, right?
I don't need the direction.
Women got y'all beat there, guys. Sorry. So, 0, 1, 2, 3, -1, -2, -3. Now, 0.76, I can draw that pretty much because I already got 50%. Where's 50%? I know that. Where? As a Z-score. That's like saying
0.
At 0 is halfway there. So right here is 50%. So we know that this is 84%, right? This is 84% by empirical rule, right? 34 plus 50. So we know what's half of 34? 17, Hubert. Then what's 17 plus 50? 67. So you know that pretty much between 67 and 84 is about 70%, right? Somewhere right in there. So you know your answer is going to be probably somewhere around, I'm going to say 1.75 or maybe 1.8 maybe. And that is a what? That is a guess. So I did my drawing. I did my guess. Now I need to actually do the math. So what do? Well, you go to the table. For those that don't have technology, you go to the table. And I'm looking for 0.7.
Why would it be 1.75? or not be just 0.75.
I just guesstimated.
And about, like, on there.
Because this is 1.7-ish, and that was 70%.
Wait, I'm confused
Oh, no.
now.
That'd be 0.7.
Oh, sorry, yeah. That's a legitimate gripe, sorry. It's the alcohol. There we go. Thank you. I appreciate you two bringing that up. He didn't bring it up, he was cheating. Thank you, sir. All right. So I'm gonna go to my handy dandy. Where is it? Just give me a second. I'm only juggling about 3 different things up here. There we go. Do we know if it's positive or negative? We know it's positive, and we know it's around 0.7-ish. So I'm gonna go down here to 0.7-ish, and I'm gonna look in this area for I'm looking for 70, did I say 76? I'm looking for 76 cents. 76 or 0.76, 0.76.
0.02. 0.
You be quiet.
Sorry.
You're not going to pass a single class here. I'm going to talk to the other instructors. I'm going to make sure they fail you. All right, 0.700. I'm finding it close up here. There's 7. Okay, here, right here. Look at there. I got 2 that are close. So how do I figure it? Well, I got to find out which one's close. So in my mind, I'm thinking 76 cents or $76. All right, so I'm going to circle these 2. What is closer? Now, please don't blurt out an answer because you're not thinking, okay? What is closer to 76? I'm sorry, that's wrong. 76. You were right. Down here, 76. 76, right here. Thank you. Okay? You're right. God, I hate it when he's right. All right, so what is closer to $76? $76, $75.80 or $76.11?
$76.11.
Thank you. I have so many students that go, 75, baby. Okay, so now you got to go back and find your change. So, 0.7, what? That's the second column. This is 0 column. This is what? So what's 70 cents plus 1 cent?
You have a work email.
0.71. So your answer to this question should be 0.71 z-score. So now let's go back to the calculator. So we go back to the calculator eventually after I have to pull it up. Hold on. I got to pull up both of them. And it's both on the same. Anybody know it? Second, bars. Actually, it's inverse norm. Inverse norm. Inverse norm is giving you the area. I mean, the z-score, you've got to type in the what? The area. 2 different questions. The first one, I give you a z-score, I want the area. The second one, I give you the area, I want the what? Write those 2 things down. That's the 2 type questions you're going to have in this first part. So I'm going to type in, and I always type in 4 digits, because sometimes they're going to give you area and it'll be in what? 4 digits. So I'm going to go inverse norm, enter, and I'm going to type in 0.7600 for 76% or 0.76 probability, and I get, it's a miracle, 0.71. Now, how do I know to round it to 2? Well, what I tell you a while ago, z-scores are rounded to what? Areas are rounded to 4. Capiche? This is one of the most easiest sections if you listen to me and you do follow the directions I give you. 7.1 and 7.2 are 2 of the easiest sections. So make sure you get 0.7063 on your calculator. All right, now, the third type question you're going to get. Now, we haven't got to the big ones that have the mean of 100, and we ain't got to those. We're still on the second type questions. But there's 3 or 4 type questions you're going to get for that second type. We went over 2. Okay, we went over the first one. What was the first one? Given a z-score, find the what? Let's write that down for some of y'all that don't write things down when you're supposed to. All right, so we're on the second type problem. That is mean of what? 0 and a standard deviation of what? 1. Okay, and these are the 3 types. 1, given area, or given a z-score, find the area. Now there's 2 more questions with that one. So there's A, B, and C, and we just did A with that first one. The second type question is given area slash percent slash probability, find the what? Find the z-score. So we've done this one, and we've done this one. We got 2 more to cover, and then you're covered for, I think it's 7.2, because they kind of mesh. There used to be 3 sections. There used to be 1 section on uniform, 1 section on these, and 1 section, it was 7.1, 7.2, and 7.3. Now they've kind of mashed 7.2 and 7.3 together into 7.2. Okay? So what's the second one? We've talked about it. The second type right here, this one is probability above, what was it, 1.6 we used? This one will be probability below 0.3. Okay, so if I give you probability below, then that's the left-hand side. Everybody understand that? I'm not going to go over that one because that's 0.3 would be where? Right here, 0.3. That's right, because that's 0.5. So 0.3 would be right in here. And somebody, I'm going to draw this in blue. There's 0.3. We know it's more than what percent? 50%. So I would say, we know that to the right, to the 1.5 right here, 0.5 is 67%. Half of 17 is what? 8. So 8, I'm going to say 58%. Everybody with me? 58% is my guess. Okay, so that's supposed to be a dot, not a mark. All right, so somebody in your calculator, let's do that. That would be inverse norm, CDF. Which way do we read? Okay, what's this arrowhead called? Negative infinity, which you can't type in, so what are you going to type in? Golly, y'all use critical thinking on that. I have some students that say 9999. So thank you for using critical thinking, knowing that you're on the left side. Thank you. All right, and go to what? Point what? And if you've got your table, then you would look for 0.3 on your z-score, and then just write down whatever you got. 0.30. So somebody tell me what the calculator gives you for the area. Give me 4 digits. Do I need to type it in?
0.6.
I'm sorry, what?
0.6179.
That's better. So I got 62, so you got 62%. I said it was 58%. Is it close? Yes.
So when we look at our table up, so we look at the table, it's a 0.00 point, because that's the point.
Let me pull it up. Hold on. Let me pull up the table. Because I need to look at it with you when you're asking me something. Okay, so the first thing I would do is find 0.3, and it's going to be 0.30. Which is that?
So you just go to the right.
Yeah. Because technically, 0.3, if you write 0.3 down, what does 0.3 have beside it if there's nothing there?
Okay.
A 0. So that means you're going to use that first column, which is right here, which is that one. If it was 0.31, then you would use this one. That's why I told you those are cents. That's the dimes, that's the pennies. Now, the last one. I know what time it is, so don't go into convulsions yet. All right, so here's the last one, and this is the one that makes y'all kind of jittery. I wish I could quit doing that. First of all, I'm going to give you a scenario. Y'all know what a scenario is, don't you? Okay, good. I don't have to explain that. Let's say that you, if you're not talking while I'm talking, let's say that you're in Anderson and you want to go to Spartanburg, Greenville, and Spartanburg. And you know that it's 30 miles to Greenville, and you know that from Anderson to Spartanburg is 50 miles. So how far is it from Greenville to Spartanburg? How'd you do that? You subtracted the smaller from the what? From the larger. Write that down. From the larger. Because I wanted to find, technically, what was in between. Now I could do that opposite. I could say if I knew that it was 40 miles from Greenville to Spartanburg, then how far is it from Anderson to Greenville? 10 miles. Any way you want to find something that's in between, you take the smaller from the what? Everybody with me? Okay. Now this is a type question you're going to see. Find the area. Notice I said area. That means we're going to have z-scores. Between (1.7) and negative 0.3. First of all, you draw what? Draw a picture. This is where the empirical rule comes in. If you can't read the empirical rule, then it's going to be hard for you to do this. All right, so negative 0.3, I'm going to do it in red, because that's the one we're going to subtract. Negative 0.3 is where?
Right there.
Right there. Right here? Yeah, that's 0.5, so that'd be about 0.3. Now somebody tell me what that around, approximately, what area is that? Well, we know that this is 50%. We know that this would be 50 minus 17, which is what? 33%? I don't know. Is it 33? Then half of 7, let's say that's half. Half of 17 is what? 8? So we could say 50 minus 8, which is what? So 43%. Everybody with me? Now you could say 0.43 or you could say 43%. I don't care. All right, so that's in the red. So that's Anderson to Greenville. Everybody with me? Now I'm going to do Anderson to Spartanburg, which is in blue, 1.7. 1.7, there's 1.5. 1.7 would be about there. And we know that that's, I think we said, what was 0.7 a while? Didn't we do 0.7 a while back? Oh well. I know that this is 84%. Half of 13 is what? 7? So.
Oh, it's 0.75. That's what you said.
Okay. All right, just let me calculate right now, hold on. 84, what's 84 plus 7? 91? So I'm gonna say that's about 92%. I have no idea, but I'm just saying that's about 92%. Everybody with me? So somebody take 92 minus 42, wow. Can y'all handle that? It's 50%. So I'm gonna say that we're talking maybe 50%. Everybody with me? Okay, so I'm gonna say over here about 50%. Now what this does is this gives you some kind of check to see if you're in the right ballpark. Okay? So somebody do your, I'm just going to do the calculator here if y'all don't mind. What's this arrowhead called? So that's negative what? Okay, so somebody do negative 9999 to 0.3. And somebody give me that. I should have wrote red, I'm sorry. Somebody give me 4 digits there.
0.6179.
0.61. I didn't do it. No, that's not right.
No,
Not negative 0.3.
it'll be
Negative 0.3. It'd be what?
3821.
Point what?
I got 0.3821.
0.3821.
That's what I got.
Now, right quick, that was not your fault. 3821.
Yeah.
You said 50, but see, the picture showed me that I was on the what? Left-hand side, and I just forgot to write the negative. So see, the picture helps you. Okay, I'm going to have 3 or 4 of y'all. Y'all not going to write the picture. I already know that. But go ahead, don't cry. And here, we said, somebody give me negative 0.9999 to, what is that, 1.7? 1.7, and I'm going to color that. Okay, what is that?
The 1.7?
Yeah, what's 1.7? Negative 9999 to 1.7.
0.9554.
9554.
Yes.
And somebody take 0.9554 and subtract 0.38, what is that, 21?
Yeah.
Somebody give me that. I'm going to write this in red, purple, right? That'd be purple.
0.5.
Shoot, I suck. There we go. What is that?
0.5733.
0.5733. What did I say? I said around 50%. Is that good enough? Yes. Now, that's this area where? Right here. Because I took Spartanburg and I subtracted Greenville. I subtracted the lower from the what? Higher. Now that's what you have to do if you have a table. Okay? You have to look up the table with 0.3, negative 0.3, and you get 3821.
comment.
And then you subtract it from, look up the table, 1.70. Everybody got that? What if you have a calculator? Which way do we read? Left to right. So in your calculator, you would go from negative 0.3 to what? Do that. Get to what? You get the same answer. So I'm giving y'all 2 ways to find these areas. Okay? Now, the only difference between this question and the next question is basically what? You're going to be given a different mean and standard deviation. Now let me check right quick before y'all go into hysterics. I still got about 5 or 10 minutes. All right, so I'm just going to give you an example right quick. And then you can maybe, some of y'all that, you know, raise the bar and go to the next homework, maybe y'all can work on something. Here I'm going to give you the mean is equal to 100. The standard deviation, that's mu, so the standard deviation here would be sigma, is equal to 20. First thing you do is draw a picture. Of course, if you have these already copied, you don't have to do this all the time. for the one person that's gonna do it. 20, 140, 160, negative 80, not negative, dork, 60 and 40. All right, you can also remember to put your 0, 1, 2, 3 here, and your -1, -2, -3 here, if you want to. And some of those that you're going to print out has the z-scores and the percentages, and that's what I would highly suggest using. 0.15, 2.35, 13.5, 34, 34. I guarantee you some of you got tired of writing it just on these 4 or 5 problems we've done. 13.5, 2.35, and 0.15. And then I say, find the area at 126. So this is IQ scores, okay? These are IQ scores. Let's say IQ scores. I want to find the area at 126. Well, you can't find the area at 126 unless you convert it to a z-score. Now, the TI-84, you don't put in 0 and 1. You put in what?
100.
And it will automatically do that. But those of you that don't have a TI, you have to change 126 into a what? A z-score, which is x minus x bar over standard deviation. X minus x bar over standard deviation. We did this back in the last part of chapter of Unit 1, I think. Remember? Remember President Lyndon Baines Johnson and Shack? Okay, we did that, so y'all should have that. So, all right. Now, I forgot to do my estimate. My estimate, let's see, 81 or 84 plus 7 is 91. I'm going to say 92%. So my approximation is 92% based on the empirical rule. So what is my z-score? That's going to be 26 over 20, which is equal to 13 over 10, which is equal to 1.3. And no, you do not need a calculator for that. So that's going to be 1.3. And I'm a little bit off because I went more than that. So I'm going to drop down to about 90%. Okay, so 1.3. So now you've got a z-score. What did I say? I just said find the area. Did I say greater than or less than? Doesn't matter. So you can just find the area to the left. So somebody, which way we read, left to right. So if somebody go from 9999 negative to 1.3 and tell me what that 4-digit number is.
0.9032.
90 what?
32.
It's a miracle. And that's how you do 7.2, second part. So remember this right here. Z is equal to, if you have a TI-84, you don't need to do this.
Okay, see, that's what I did.
Now we're going to do some more of those when? Tuesday, yes, tomorrow, which is Tuesday. So when y'all get back, we're going to be going over 7.2 material. What does that mean? Test coming up, probably Wednesday or Thursday or whatever. Okay? Y'all get out of here. I'm just going to say everybody was here. Where's Mr. Ayers? Isn't there we missing a third row back there? Does anybody know where he is?
I was with him.
Okay, well maybe he's just working on his own. That's fine.
Hubert, I have to say something about him.
Oh, no, tell me nothing. I don't even know nothing.
No, it's funny.
I got to turn off the recorder.
Okay.
Why are you going to stop coming?
You might be right, President.
Okay, go ahead.
That's gonna be the day.
Remember what I told y'all. First, if you don't like being here, what?
Don't come.
Stay home.
No one said it like being here.
Well, why would you not come?
How is that non-validated
It's
word?
a drive in the morning.
Oh, yeah, it's really awful.